Hi everyone, together we will go through a tutorial from the Galaxy ecosystem which is called Pangeo Notebook in Galaxy, and this is an introduction to XRA. So to get to the tutorial, we can first go here in the hut, and it's in the climate section, and it will be this Pangeo Notebook in Galaxy introduction to XRA. I really recommend you listen and watch this video. This is a slides explaining what is Pangeo and the Pangeo ecosystem and all the different tools we have in the Pangeo ecosystem. So now we go directly to the training material here, to the hands-on. In this hands-on, we will be using an interactive tool in Galaxy, which is a Pangeo notebook, and we will learn how to manipulate Earth science data using XRA. So XRA is a Python package. So this there is some requirement to follow this tutorial, and you need to be sufficiently proficient in Python. I really strongly suggest to at least have an introduction to Python if you don't know Python, and you can follow Python's the introduction to Python from the Galaxy ecosystem, Galaxy training material. Okay, let's start here. Okay, so we will first create a new history, and we will call it XRA with Pangeo. So let's start and create a new history. I will click here, and then on the plus button, and I can create a new history, and I type enter to make sure the history name is taken into account. Then let's go back to the training material. I will now upload some data. The data we'll be using for this training material, and we will be using some data in netcdf format, and the data is from the Copernicus Atmosphere Monitoring Service. So I can click here to show you a bit. So netcdf is a very, very common format in climate science or in weather forecast. Here to download the data, normally you need to log in and register. But of course, for this training, we have prepared already a sample for the training material. All the data from the Copernicus Atmosphere Monitoring Service are free of charge. You just need to register to get access to it. I will copy here the link, and then I go back to my history where I can upload data. And I will paste and fetch and paste here the link to the Zenodo netcdf file, and usually I even set here the format to netcdf. You could leave it as is, but sometimes with some netcdf file it is important to specify the format, so it's better to always set it. And then you click on start to upload the data into your history. So it's green here, and now the task is gray. It means this is queued, and once it will be running, it will be in orange, and then finally in green when it is completed and successfully completed. We can, in the meantime, go back to the training material to see what is next. So the data we have uploaded is particle matter for particle lower than 2.5 micrometer. So these are very tiny particles. These particles have an impact on the health. They can provoke eye irritation at high concentration or asthma, or they can be problematic for people having bronchitis. So now the task is running. I see here this is in orange. And then the next step will be to start the Pangeo notebook. So this is a Jupyter Lab in Galaxy. It's an interactive tool which you can start from any Galaxy Europe flavor. So not all the main Galaxy server have interactive Pangeo notebook. Check it out before. Then I will click here to start it. Another important aspect before you execute here and start your Pangeo notebook is to make sure you are logged in. Interactive tools will not be working if you are not logged in. Now the task is completed here, and this is an .cdf file. So I will start from a fresh notebook, but I will select the dataset so I can use this dataset to analyze and visualize the data in my Jupyter Lab. And I click on execute. And again, it's gray, so it means this is queued. And then it will start, and it will then will be orange, and it will remain orange during the entire session, which means the interactive tool needs to be running while you are using it. And then when you are done with the tool, it needs to be stopped, which I will show you how to do that. So here it is queued. It usually takes between 5-6 minutes before it is completely started and you can use it. So here we can see that the next step will be to upload the Jupyter notebook into this interactive Jupyter Lab. So I can already copy here the link. Let's go back here. So here this tool is running, and to get access to it, you go to the user tab and active interactive tools. And then once the link is active here, so it may take a bit of time before you are able to link and click on the link here. But once this is active and running, you click here, and then your Jupyter Lab starts. Be patient. Okay, so now it's starting. So this is a classical Jupyter Lab, and here we have one Jupyter Python environment, which is a Pangeo notebook with all the Pangeo packages you need for analyzing and also to visualize Earth science data. We will open a terminal here. I will make it maybe slightly larger so you can read. You can click here to remove and make it larger, and past. So I right click to past the line we have copied from the tutorial and to upload the Jupyter notebook in this interactive environment. Then once it is done here, if I click on the file browser here, again, now I have a new file. I can make it slightly larger, and you see this is the climate Pangeo notebook, which is the one we have uploaded. So if we go back here just quickly on and click on the hat to get information on what is next, we will see that from now we will mostly use what is in this Jupyter notebook and will not have to go back to this tutorial. Okay, so let's go back here, and I left click to start the Jupyter notebook. The data is in the data folder, so we are all ready. So now you have to select the kernel, and we can select this one, the default one, which is the Pangeo Jupyter notebook. I can left click on the file browser to hide it and have the Jupyter notebook on the entire page, and I will make it slightly bigger for you to read. Now we will stay on this Jupyter notebook, and you can follow step by steps, and you will learn how to use an Xarray to open an etcdf file, which is here data from Copernicus Atmosphere Monitoring Service. This is the particle matter for particles smaller than 2.5 micrometers, and this is a 4-day forecast starting from the 22 December 2021. So first step is to install any packages you may need in your Jupyter notebook. So here we will install a package CM Primary, which is a package for using custom color maps or colorblind friendly color maps. So let's execute, Shift Enter to execute this cell. And then you can import the packages we need for this Jupyter notebook. You can see the color maps here. We'll use a bit of Panda, but not much. Some Cartopy and Matplotlib for visualizing the data on a map. And the most important here, this Xarray, and of course NumPy, which you may know, and we use very little because most of the time we remain in the Xarray world. First step is to open the data. So I will not go through all the different steps, but I want to show you what are the main important steps. Here I will execute this step. The first step is to open and read the metadata. So when you open data with Xarray, with here using this open_dataset, here we only open one file. When we want to open several files in one command, we use xr.mf underscore open mf dataset instead of dataset. So there is a mf for multiple. So let's execute this one. When you open a dataset with Xarray, you don't load the data into memory. You only load the metadata, which you get here when you print, for instance, the dataset. So printing the dataset only prints the metadata of the dataset. And here you can recognize what we call Xarray dataset, where you have dimension, coordinates, with here the longitude, latitude, level, and times, all the times, for all the different forecast times, and the data variables. Here we have only one variable. We could have more than one, and here this is a coordinate and the size of the variable, here this particle matter, and some attributes. So every single dataset normally has attributes, and here they are trying to use the CF convention, which is a set of convention for easing the analysis of data. And when you print one single either coordinate or variable, you have the values, but you also have additional metadata. So the metadata for this coordinate or for this variable. So you will have to answer a few questions about the dataset, looking at the metadata. And then the second part will be to learn to select and subset. So we'll have two kinds of selection. The first one will be from coordinates. So if we look back at our dataset, so for instance, here this particle matter. The particle matter has as coordinates longitude, latitude, the level, but there is only one, and times. And when we select, we will learn first to select choosing either a subset of longitude, latitude, level, or times, or one value. And this is what we will do in this first select subset from coordinates. And for this, you are using .icell or .cell. So we'll see all the different ways to select by indexes with icell or by value. So you go through this, and we have a section where you will learn to plot, and we'll show you how to plot NetCDF data, how we shift the longitude to make sure there is no blank line in the middle of a plot. We ask you to answer a few questions about the data set, and we make some more complex selection, but it's always the same principle. We also look at how we plot multiplots, so have all the different times. For instance, we would like to visualize on one single plot. So this is this section here. And you also again have to answer a few questions. And then finally at the end we have a final other type of selection, which is what we call the where method, which is a bit more complex than selecting by coordinates, but this is to select or subset depending on the values, either from the values of the coordinates or from more often from the values of the variable itself. So here, if we take here, this is a particle matter which is visualized on a map. This is of a small region of Italy. You will see when you do the tutorial, but we can hide or mask some values to highlight some feature. And this is what we do with the where statement, which you will learn at the end of the tutorial. And I think that's it for this tutorial. We also show at the end some reduction operation, which is to make some mean average and many other reduction methods you can apply to take the minimum, the maximum values, etc. We'll also use how to resample the data, which can be very useful. So to change the temporal frequency of your data. Of course, be careful when you subsample, so when you try to add some more data. And then you have the conclusion. So you will go through all the different steps. If you have any question, please do not hesitate to ask.